Okay, another day where I'm out, but another day that we are going to be okay because we're going to make a nice video. Today is day one of related rates, and basically this should kind of give you a little bit of an idea of what you're doing, but I want to imagine like if we were going to differentiate with respect to time. So just imagine that we were differentiating with respect to time, which I know that seems strange, but now we know that the dt is not going to match the v, it's not going to match the r, it's not going to match the h, it's going to be a bad thing. So when we take the derivative, it's going to be a kind of a mess. And not only that, but we're going to have a product here, right? A product rule with this green and with this blue. So let's try to think about just what the derivative would be. What's the derivative of v with respect to t? So that's going to be dv dt. We have to use that because we can't get around this. The variables don't match. Now we look here. What's the derivative of this? Well, we got to now do the product rule, on this. So the derivative of the first is going to be 2 pi r. Variables didn't match, so it's dr dt. That's the derivative of the first. Times the second as is, plus derivative of the second, variables do not match, times the first. So that is going to be how we're going to proceed from here on out. A lot of the times we're going to differentiate with respect to time, and we'll see how a lot of different rates, these are all rates like meters per second and feet per minute and liters per hour. We're going to see how those rates are connected. As one rate changes, how does another rate change? But don't worry about the application yet. Just try to understand that now the variable doesn't match anything. We do everything we've been doing, but now we have a bunch of dt's here. That's really all I'm trying to show you with this first problem, is that you need to kind of just do what you've been doing, but every single time now. There's no dx here. There's nothing good about this really, and to be simple, to be straightforward with you. Okay, so now let's look at a problem where we have a dx in this case. So it could be with anything. It could be dt on the bottom. It could be dx on the bottom, right? It could be over dy, right? It could be anything with that, with respect to. But in this case, it's dt. But if we look at this next problem here, we want to find, well actually, let's look at this. We want to find dy dt. So dy dt, right, is equal to question mark. So I guess it's pretty clear that we're going to have to use this with d dt. That's a t. So let's look at it. Suppose these are both differentiable functions of t and they're related by this equation. So let's do what we just did in the last problem. What's the derivative of y with respect to t? It's dy dt. Then let's look here. We got x squared. What's the derivative of x squared with respect to t? Well, we can do our normal power rule, but because the variables didn't match, and I know this is new for you because usually the x's are the good thing, but in this case it doesn't even match because we're doing it with t instead of with x. And we would love it to be x so that they would match, but they don't. Derivative of 3 is still going to be 0. So this is done. This is our equation, okay? And now it looks like they're just giving us some helpful info that we can plug in to figure this out. Do I have a highlighter? I don't know. Okay. Well, it looks like x is 1, so I guess we'll put that there. And it looks like dx dt is 2, so we'll put that there. And we just want to know what dy dt is, so dy dt, I guess then if we plug in, simply plug in, it's 2 times x times dx dt. So I guess that dy dt is simply 4. Well, I don't guess, I know that. But just trying to empathize with you guys, help you out. So basically what you're going to do is what we did on the last page. Hopefully it made some sense. And then you're going to plug in some stuff and find one of the missing things. It could be dx dt that you're finding, it could be x that you're finding, it could be anything. But you're going to have all the missing information except for that one thing. So a little bit further with this. This is just a trick, okay? So maybe copy this down. Whenever you're going to do these problems, you're going to get some word problems. Not yet, but when you do get a word problem, I want you to first draw a diagram. Then I want you to make a box like this that contains all of your rates. So maybe one rate is dy dt, and they give you that, okay? Put that in there. Maybe you're looking for dx dt, okay? I'm just giving you an example. That's what we're looking for. We know this is -2. Let's say they gave us x equal to 7 at that certain time, okay? So you're going to make a box. This is a box with all of your rates. Then you want an equation. So you want to write an equation like there was in the last two. And it's at this point, after all of that, that we differentiate. This is where the calculus comes in. Okay. And then once you've differentiated, you will finally substitute. Oops. Looks like there's no way around this one. That was so much more work, you know. And solve. Okay? I'm not going to push you to do all of this right now, really. You're not going to need a diagram. It's not going to need to give an equation. I'm going to kind of do some of this for you. And then I'm just going to ask you to differentiate and substitute solve today. We're going to get into related rates as time goes on, but for right now we're just kind of getting into the basics. So here's one example, and I'm looking in the book right now, and I'm hoping that you will pause the video and turn there if you're not looking in the book. At this ripples in a pond, and I'm going to try to follow dreads just for you, and this is about as intense as we're going to get today. But if we're going to follow dreads, we're going to need a diagram. Okay, and we have, in this case, a pebble dropped into a pond, so we have a bunch of circles. And as time goes on, these circles are kind of just growing, right? It's a ripple effect, and they kind of just keep growing out. Okay, so that's what we understand about that. That's the diagram. And then we want to see if there are some rates. So, of course, you can pause and read the problem. I'm just going to assume that you've read it. It looks like the rates that they're giving is they're giving dr dt is equal to 1. So we're going to make that box I talked about. Looks like dr dt is equal to 1. That's just straight up told. And it looks like I don't think they give you anything else except for when the radius is 4, so when. And this is a certain time, so I do want you to understand, we'll get more into it later, when r equals 4, because granted the r doesn't always equal 4, so let's just keep that in mind. You don't want to substitute this r equals 4 in until you've differentiated. I will stress that big time in person, but for right now, that's just something I want to at least hit. And then I guess we're looking for dA dt, so I guess I would say since we're looking for the rate of change of the area with respect to time, I'm going to make that my question mark. So at this point, I guess we need an equation. And an equation that relates this diagram is the area of a circle, right? Area equals pi r squared. So that's good. And really at that point we're ready to differentiate. So if we differentiate, what are we differentiating with respect to? Take a look here, we have some t's. So we have to do it with respect to t. I'm not going to expect this blue notation that I'm doing right here all the time. I figure you'll just get there. But for right now, I'm trying to show you that we're using the t. It doesn't match the a, so it's dA dt. It doesn't match the r, so we're going to actually have a dr dt. We have the power rule and an extra dr dt. So this is our new resulting equation after step 4 right here. And then we are just left to substitute and solve. So grab this stuff from up here, right? R is equal to 4. Dr dt is equal to 1. And we're just going to plug that stuff in and solve. So solve after you substitute. So then in this case, dA dt is equal to 2 pi times 4 times 1. So I guess the ADT is equal to 8 pi.